Now let's talk about something fun. Let's talk about how arrays are stored in memory. So when we declare an array variable like this, where you have an int, you have an array variable a, and it has a size of 5, the compiler allocates sufficient memory to store 5 ints. Now, in consecutive location, that's an important point. These elements of the array will be next to each other in actual memory. So, you know, A index 2 will be right next to A index 3. And the location of A indexed 1 will be exactly 3 int sizes away from A index 4, right? In fact, if you look at what the variable A is, it is actually, and if you actually try to print it out, it is actually the location in memory of A index 0, right? And A index 0 is exactly 4 bytes. That's the size of an int typically, 4 bytes away from the next element, A index 1, and so on. So we can actually, look at this in code. So let's actually copy this code in the IDE, and then let's run it, and then I'll talk about it. So I will copy it here. Let's go to the IDE, right, and paste this here. Right. Let's talk about what is going on here. So I have my declaration, the one I showed you, that's right here, right? And now I am going to actually print A, and we're going to see what exactly is that. And then I am going to print the location of each of the 5 elements, right? And I'm using this operator, ampersand operator, that allows me to get to the memory location, or access the memory location where that thing is stored, right? So let's take a look at that. Let's run that. Right. So what you see here is a bunch of hexadecimal values here that represent the memory location where those things are stored. So A here, in fact, is the same location as A index 0. These are exactly the same. So the variable A really points to the first place, right? And all the subsequent ones you will see are exactly 4 away from the previous one. Now, from here, it goes to C because, again, we're using hexadecimal math. All right. Now, what happens if we run it? Will we get the same thing? Will we get A00 at the end for A? And in fact, you run it again, it might put A in a different location. So let's actually run this again and let's see what happens. And you see, no, it put it in some other location. If you run it again, it allocates the memory in some other location. You see that where A is being put in memory uh, is different every time. Now, after the program ends, the runtime system will recover that memory, so the memory is not being kind of lost. Okay, so let's go back. Right, so that's exactly what I'm seeing here, and then the ampersand operator is really the memory location operator, right? Now the other thing to note is the contents of the array, right? When you declare it, because you haven't initialized it, are unknown. You do not know what to expect there. So if you actually set some of the values, like here I set the fourth location and the first location, then those elements will be updated, right? Now, a couple of things you have to be careful about. If you index an array with a runtime value like I, where I holds a value at runtime, is determined at runtime, you have to be careful. For example, if in the above case, if I, for example, becomes 5, then you will get a runtime error, and because the indexing would be out of bounds. Now, where can this typically happen? This can very easily happen if you're using for loops, right? You might be off by 1. Right? Now, the other thing to note here is that you cannot use the assignment operator to copy arrays, right? So if you have two arrays, A and B, you cannot do this. It does not make a copy because these are memory location. This actually will give you a compile time error. To actually make copies, you need to create a proper loop and copy it element by element, right? Now let's talk about initializing arrays, right? Now you can declare arrays and initialize them in one statement, in one declaration as follows, right? You obviously have your declaration and you can say equal to, and then within curly braces, you can give it the values. Now this is the same as declaring it and then following it with the three assignments, right? Now, what would happen if the number of values that you gave was less than what was needed? So here, what if I only give it three values? What happens to the last values? And actually, it would, for anything that's missing, it would initialize it to zero, right? Is an experiment you might want to try. What happens if you give it more values, right? And try that out and see what happens, right? Okay. Now, if an array is not initialized, as I said earlier, you don't know what to expect in the contents. And so what exactly does it hold if you don't initialize? So let's actually try that out, right? So here's a piece of code where we're just basically declaring it, not initializing it, and we're printing the values, right? So let's actually take this. I'll make a copy of it. We'll go into the IDE and we will paste it right there. Okay, that's done. Now let's run it. Let's see what exactly does it show. What are these elements holding? If you run it, you will find it's got some interesting things. First two happen to have zero. The other ones seem to have a garbage and stuff like that. Now, if as previously I had said that if you rerun this program, it would might put A in a different location in memory. So let's see what happens if we run it. Right? Do we get different sets of garbage? Right. So we are getting some different values here. Because that's just how where things got put. All right. Now, lastly, we have a convenience thing here. Now, since you are providing three values here, you can skip the giving a size because the compiler can deduce that this is uh, an array of size 3.